Looks like Tyler and Lawrence and Chelsea. Hello, are you there?
Yeah.
Okay. Um, I think that. So, did you all get the new updated ALA 16?
I haven't had a chance to look yet.
Okay. Well, let me just put it up here real quick. Um, okay. There it is. And the all I've really done is say, for this table 2, instead of having 9 cells, we're only going to work with 4 of the cells. Okay?
Okay.
That just means that the other 5 cells, I decided that you'll get the gist of what happens with just 4. We don't really have to do 9 to demonstrate the concepts. All right? So that's the first thing. In class today and yesterday, there were some questions about this, C, D, and E, okay, which were still not very clear in people's minds how to do that. So that's essentially what is that what you all want to go over today?
Yeah, I kind of left off stuck on C. I had run some regressions, but I wasn't really sure where to go from there.
Okay, all right. So just to make sure everybody is on the same page. I don't know if anybody's recording this or not, but just to make sure that everybody's on the same page for this. There's we had a module that was called Quantitative Genetic Models, and in this Quantitative Genetic Models, there's a graphic in there that this is all based on. And in this graphic, we just say we have alleles. We have a desirable allele and we have an undesirable allele. And they're either available in 0 or 2 copies. Or sometimes if you don't have double haploids, you'll have just 1 copy. Okay, so that's all we're trying to do. But I think the issue for folks is that prior to this, they're in simulation mode. You're in a mode where you're thinking, I'm creating some phenotypes. And I'm creating those phenotypes based on segregation at a bunch of genetic loci. And then, as you switch from B to C, suddenly or question 1 to question 2, we're no longer in simulation mode or creation mode. It's kind of like, and this is something I do with my research group all the time, is I say one group of people, your job is to simulate, and another group of people, your job is to evaluate. It's kind of like what you do with experimental things. You have a bunch of materials, you put them out in the field, and you evaluate. You didn't get to create those materials. You're just going to evaluate them. Well, in this case here, you get to do 2 things. You get to create the materials, and you get to evaluate the materials. Okay, so this is essentially what we're doing now. Is in CDE, we're evaluating the materials. So that transition is that now we basically have to get out of the creation mode and into the evaluation mode. Okay, so let's just say, so, you know, I've made this table smaller. And out of this table, what I want to do is I want to select some of this data. Okay, and I'm going to put this onto a CSV file. All right, so I've got family A and I've got environment 1 and family B in environment 1. This is only one replication right now, okay? And I'm going to change all of these loci, their genotypic scores. I'm going to change those things into a numeric. Okay, and so I'm just going to call this, you know, marker locus 1, and I'll say if this is equals if whatever this is, E2 equals GG. Oh, I see what I need to do. Actually, what I need to do is in this first family, it's not segregating at all. So I'm just going to say it's marker locus 1, and it's going to be 0. I'm just going to arbitrarily say that the AA is the better allele. I don't know if it was or not in my original data. I should probably go take a look at that. So marker locus. So I decided that CC is going to be positive. I don't know what I decided for GG. They're not segregating in any of those. Well, they should be down here. AG. Oh, I know what's, yeah, it's going. So I still haven't filled them in. So anyway, they're not segregating, and if they're not segregating, they're zeros. And if they are segregating, there's something other than zeros. Now, are they segregating if for family 2 in these data? Well, I have to go back to my instructions to tell me if they're segregating for family A or for family B. So what's family B? Okay, for family B, they should be segregating at locus number 1. In fact, with this new thing, I think they're all segregating. Occasionally, some family isn't segregating. Okay, so anyway, let's. So for marker locus 1, we have zeros, and then down here when they go to family B, we should have this switch over. Okay, and so this is where we need to say equals if GG, and I don't remember if GG is positive or negative right now. I'm just going to, and I don't think it matters too much. Logical test equals GG if this cell here equals GG, and I may get some pushback on my syntax because I don't know this system very well. And then the true, if it's GG, then I'm going to give it a 0. Otherwise, I'm going to give it a 2. And so that's the first thing. And then I'll go all the way down to the end of family B, and now I've got a bunch of 2s and 0s. And back up, so marker locus 2, I think it's segregating, and so in this case, is it segregating in both families? Looks like it is. So in this case, it's real similar. It's equals if this locus here, F2 equals A or CC, then if it's CC, again, I don't remember if it's positive or negative. I'll just say it's 0. But it turns out it doesn't matter because you always have to, it comes down to interpretation at the end anyway. And so this whole column is going to be 0s and 2s, and then marker locus 3 is 3. Since it's AA, and it's not segregating in the first family, and I don't remember if it must be segregating in the second family. Well, it looks like it's not. So it probably doesn't matter then for this one. Although it should be segregating in locus 3. Let's go back to the instructions. It seems like it should have been segregating. Locus 3 should have been segregating, so not sure why it's not, but let's fix that. Locus 3 is segregating in half the families. It should be segregating in half the families. And I'm not sure why it's not in my original data, in my worksheet data. So locus 3, why is it not segregating when I go to family B? For whatever reason, I decided to not let it segregate.
In the early version of the assignment, there was no segregation for that locus.
Okay. All right, so locus 1, locus 2, locus 3, and in family B, it's supposed to be segregating. Let's see, okay, so I want it to look like this. Now, why isn't it copying for me? Control C and hit the enter and come over here. Okay, now it's if F53. It's not F53, it's FGH. H. Yeah. Okay, that's right. Yeah, so I've still got this original data here. All right, that'll help a little bit. Oh, I didn't do it right, did I? I got it in the wrong place. FGH, so that's still correct. You guys that are better at this probably like this bit. It would be much better at this. But anyway, so now I got locus 1, locus 2, locus 3, and I can, I've got them not segregating in the first family, but they are segregating in the second family. I'll just use that to replace what I've already got. Let's get the other file up. Locus 1, locus 2, locus 3. So paste the values. And let's see how that works. Oop, so I forgot one too many. I don't think this one matters. Alright. Now we can get marker locus 3, which is 0 down to, then we get to the second family. And in this case here, it needs to say the same thing as it says here. But that's not E52, that should say G52. Whoop, that wasn't right. What happened there? Oh, I know why. It's T's and C's, isn't it? There we go. And then I have a bunch of phenotypes that I have to bring over. And let's see if we can come up with the phenotypes. Okay, and there's a problem here. CC, okay, I want to do this here also. Now, I'm going to tell you right now that these numbers that I'm putting in here are probably not right, okay? So if you see negative 1535 or 1535 or these other things of 1524 and so forth, those are probably not right, okay? I'm not being very careful with those right now. But I have a phenotype. I also have to, so these are the genotypic values. And let's see, we can go to question 2, and I have these genotypic values. Oh, there's the residuals. Okay. Yeah, so I want to get these genotypic values for these. Oh, don't want it for family C, just family B. I want to put those over here. Okay. Yeah, I did. All right. 230, and I don't remember. So in family B, what was the mean? I want to make sure that this is, at least part of this is the way you're going to find it. There it is. So family B is 205 and 220. All right, so let's come back over here and take a look. 205 and 220 for family B. Oh, okay, so 220, this is 205 because this is environment 1. Is that right? Did I get that right? According to the instructions. Family B, environment 1. Okay, good. All right, so now I have a set of phenotypes also. These phenotypes need to also be brought over to the to my actual I made a mistake. Come back and do that again. And there's something. Okay, yeah, that's right. All right. Now, so this has just been my worksheet so far, and these values here we need to get. So what I'm going to do here is I'm actually going to take these values and move them somewhere else. The reason I'm doing this is because, you know, I'm going to want to feed this into a an R script. Okay, so now I have some loci and some phenotypes, and I think I can now. I want to save this and use some R script to analyze it. All right. Now so it's now that let's just make sure that this you know what are we trying to get to? You know what's this data set that we're trying to evaluate in order to answer the questions for C, D, and E. Okay, and so there's going to be environments and reps and families, etc. And I said you should probably try to do these things first of all by environment and by family. And in this case here, I don't have 2 reps, but you could imagine that I have the 2 reps. The main thing is to just try and find out if there's any slope associated with any of these loci. So let me get RStudio up and running, and let's get a new file, new R script, and this isn't the right R script that you guys are going to want anyway. What we want is some kind of regression script. And the regression scripts that I gave, and so what we'll do is we'll go back to the original stuff that I handed out to people. So there's R code regression, example regression. So now where did I put that data set? And I think I put it under something called, okay, so I'm just going to put it on my desktop. Okay, so then I'm just going to call this a data set. Data set, read this thing here, and we'll call it ALA 16 Geno and Pheno. Do I want to worry about environments? Yeah, at some point you do have to do this, but for right now, I'm going to skip most of this factor stuff. Because, like I say, eventually you have to worry about these things, but not right now. Let's take that out of there. Take that out of there. It's not called M-score. What have I called it here? Oh, I got a bunch of different names for it. Okay. Locus 1, Locus 2, Locus 3. All right. Let's make sure I can read it in. Looks like it has no trouble. Let's attach that. Let's take a look at this. Now what it says, oh, it's that darn M-score again. Plot. What did I call it? Locus or LOC? Locus, LOC1. It's not called yield. What did I call it? Pheno. Okay. All right. So what does that plot look like? All right. Do you all see this plot now?
Yes.
Okay. And you see there's 0, it's at 0, and it's at 2. All these data points are either going to be classified as 0 or 2 for the phenotype. I don't know what would happen if I expand this.
How do we know what goes into PCH? Where you have PCH equals 20, so why is it 20?
That just tells it what kind of data point. It's we could try. Let's just try 10. What happens if we say 10?
Oh, okay.
Okay, it's just a symbol.
Okay, thanks. I wasn't sure what that one was.
Yeah, that's all that is. And then there's this. Okay, and we could put a line in there if we wanted. Whoop, I have to do this first. Okay, I've got YLD again. So it's pheno is due to that. And then AV line for pheno. Oh, it's yield. How about if I change the name of this? Pheno, all environments. Maybe I ought to call this environment 1. environment 1. And now this is averaged across both families. And so we're going to come back and adjust this a little bit. Pheno.env1. Okay. So there's pheno for environment 1, and there's a line that goes in there. And what you see is that if you have at locus 1 a 2, I don't remember what, is that a G or an A? I don't remember. But anyway, if you have an A, then your slope is going to go downhill. And so that means your better allele is whatever is for the 0. We can all, but this is across both families. We can also ask for, or we can take a look at this pheno in environment 1, and you can ask about the coefficients, okay? And so what is the slope of this line? The slope of this line is -11. So what does that tell me? That's telling me that as I replace one of the alleles, let's just say as I replace the AA allele, I'm going to lose 11 units. Okay, so if I get to here, I should be around 210 because I'm here at 221, and that's about right. And then as I replace the second allele, I'm going to lose another 11 units. So that's how to interpret what that slope is, and the intercept is, if I've got the homozygote, whichever homozygote I said was 0, is I'm going to be at 221. It's going to be my value. Does that make sense, what I just said?
Yes.
Okay, so now just briefly, let's take a look at what did I simulate it as. So that's what I estimated it as, but what did I simulate it as? Okay, and so this is the estimated average test cross effects for locus 1 for each of the alleles. So, and again, I don't remember as we went through it, the A allele or the G allele. And this is averaged across both families. I'll want to look at it by family in just a second. But I do want to come back here and say, okay, what in the world was what in the world did I start this off as? Okay, let's go to here and come back up here. So locus 1 is GG and AA. And that's averaged across both of those. And what was the actual amount that I simulated it as? Well, I simulated it as, either plus 15 or minus 15. Yeah, that's not quite right here. So that's not how it turned out in there. Oh, there it is. Yeah, genetic data. These two columns are confusing. They don't need to be in there. Whoop. I don't like that. I want to delete columns, not rows. All right, so that's better. So this is saying at locus 1, this is the impact, but as you can see, that impact comes from only one family. The other family is not having any impact on the results at all. Does that make sense? And because it's not having any impact, it's kind of swamping or diluting, if you will, diluting the estimated effect. because it's not contributing in the first family. It's only contributing in the second family. Locus number one. Now locus, we can now the next thing is let's see what in the world happens as I go from one family to the next. Okay, so
I have a question though.
okay, go ahead, Boris.
Going back to the Excel sheet,
Yep.
we saw that I think one of the genotype had 0 and the second genotype had 15.
Meaning one locus, or do you mean
At locus 1.
at locus one? I have either segregating AA or GG. Yep.
Okay.
Or it's not segregating.
No, they are homozygotes.
That's right. Yeah.
Yes. So my question is, so
I said if it's homozygous, it's not contributing anything.
Okay.
Okay, because in that family it's not segregating, so it can't contribute anything. I could have put it as a negative 15 point whatever, okay, or a positive 15. I could have done that.
I see.
But I chose not to because I wanted to investigate what's the impact if it's segregating in one family but not the other family.
Okay.
And I sort of didn't want that to swamp it out.
Sure.
And I've got this issue. Well, that's not the good place for it.
All right.
I'm trying to follow the instructions for the that 2x2 table.
Okay.
Let's see. Yeah, so this 2x2 table is what's kind of driving me to do this.
Yeah. All right. Now it makes sense. Yeah.
If it was the heritability, if I wanted it to be the heritability averaged across families, that would be kind of a different issue.
Okay.
And you would simulate it differently, and then you would use 2PQ, of course 1 plus F. But P and Q averaged across families each one would not be equal to 0.5. Across both families, 2/3 of the values would be GG or AA, I forgot. Does that make sense?
Yes, yes.
I wanted it to actually be done on a bi-family basis.
Okay. Thank you.
Hopefully, that's a good question. It's something to... and so the other thing I wanted to do is I want to make a subfamily, or I want to do analysis by only one family. Now I'm going to do this on the wing. I really don't know how to do this, or I haven't done it in a long time. And let's see how I do that. Let's say I want data set family A. And in dataset family A, I want
subsets.
Yeah, is there a subset? And now I put in DS.
Yeah.
And then I have to put in some other parameters.
Yeah, comma. And then I don't know what was the name. The name of the colon for family equal to.
Yeah, let's look at that. Yeah, it's called FAM.
Yeah, FAM, yeah. So FAM equal to A. Yeah.
FAM, is it double equals?
I think so.
Yep, I posted the code that I got to work in the chat.
Okay.
But yeah, it's double equal.
Yeah.
Are there any other parameters in this?
No, I think that should work.
So now we have dataset family A. And I'm going to detach DS. And And the next thing I want to do is sort of do the same thing as I did here, but I want to do it on, okay, then there's also a family B, isn't there? Do I have to attach it again first to make it work? Probably. Okay. Next thing I want to do is borrow this code again and slightly modify it. And let's see here. Attach dataset family A and plot locus 1 pheno. For environment 1. Locus 1. Okay, so this looks to me like that should work. So what do we have here? So I plot this and it says, you know what? I see data in here that's kind of down here and up here, but I really, there's no zeros. They're all at 0. So they're kind of meaningless. So locus 1 is not related to any kind of segregation in family A. And then we'll do family B. You know, what I probably should do here is, well, it doesn't matter too much. What I'm doing is I'm replacing these pheno environment 1 every time I do it. So this says, oh, I probably have done something not quite right here. Probably should be. What you can see is that I haven't changed anything in here. This plot is different, but inside here it looks like it's the same. And so that makes me a little worried that I've kind of done something goofy.
When I was working on it last night, if I didn't change that, like we have pheno.env1, if I didn't change that each time, it stayed the same, I found.
Okay, so it's not writing over it like it's supposed to.
Yeah, that's what I was finding last night anyways.
Yeah, okay, that makes sense. Okay, so this is pheno for for FA in environment 1. We want to do that, and then we also want to do it for FB. So, yeah. Dataset family A, is that what I wanted it? No, I wanted it to be pheno something or other. There it is, pheno FB.
Do you have to change it though then in that regression, that line of code for the regression line? The AB line?
Yes, that's what I just did. Oh, this AB line? Oh, yeah, that's right. That's a good point. No, I don't know. Let's see. Let's go back here. AB line for pheno. Yep, that's right. Let's do this FB dot environment 1. You're right. Well, that all looks like that's okay. It was doing it anyway, wasn't it? But if I look at pheno for family B and I look at my intercept, what I see is that for family B in environment 1, my intercept is 202 and my slope is negative 1.7. That, yeah, that's what it looks like. And that sort of looks like what, this thing here. Coefficients. Yeah, okay. Family B, environment 1. I wonder if that's really what I did. Did I really get family B, data set family B, fam equals B? Okay, looks like that's what it did. pH51 to whatever, and there's the phenos and locus. The locus 1 should be segregating, shouldn't it? In family B. And is that exactly what happened? Locus 1, family of SFA, FB. Yeah, it looks like that all worked out okay. And if I do it for family A, well, let me detach this thing. All right. Yeah.
Me too.
Yeah, so for family A, everything's 0. And it looks like that works. And if we ask it for, what is this, pheno FA? Let's see it up here. There's pheno FA. Yeah, coefficients are not, they're not applicable. This has an overall average of 228. Then the next thing, of course, is to try and redo some of this with the different loci. So let's try family B and let's try locus number 2. I don't think any of this has to be changed other than that. And it looks like there's a little bit of... Now, the thing I haven't quite figured out here is, and maybe it's doing this, I know why it's doing this. It's doing this because I haven't added any random variability to those phenotypes, have I? I was saying that there's only 3 types of values here. Maybe that's indeed the case. But anyway, that's, then we can open that up, family B again, and say, what's the slope on that? And what's the intercept? And no, it looks like it's not changing. For locus 2, is it? So it may have to be redone. Locus 2, it should be. See, with locus 2, could be that I've made a mistake with the phenotyping. But so, are you getting sort of the this? Yeah, okay. So that's right. That's what's going on here. Is I haven't added any random phenotypic variability into this pheno. Yeah, that's right. So I haven't. So I've got the mean added, but I did not add on any kind of random variance. I don't know what this is. Anyway, I still need to add in here in my simulation. I've still, at this point, my phenotype doesn't have random variability built into it, and it still needs to be built in there. So that's why I'm getting these funky, goofy-looking plots where I've only got 3 data points. Does that make sense?
Yes, I think we did not add the residual effects.
Yeah, that's right. I didn't include any of the residual.
Okay.
And so in my simulations, I didn't. Mainly, I was just doing this as a hurry to try and get to the point of, well, how do I do this? This question, this C question, and so the estimate's going to be different because now D is operational test cost breeding values for each of the parents. What that basically boils down to is saying, okay, what's the average effect? So let's talk about each of the parents. So there's an elite line, and there's a new line 1 and a new line 2. And the operation, if you look at Rex's book on page 63, this breeding value, in a very operational sense, is just what's the value of all the children that this elite line produces. Well, all the children that this elite line produced is, the children from a cross with new line 1 and new line 2. And new line 1, it's only been crossed with an elite line, so its breeding value is just the average of new line 1 when crossed with elite 1, with the elite line. Does that make sense? And what is that value relative to the overall average? The overall average includes, is basically the average of the elite. So new line 1, its breeding value will be compared with the elite, and it's just the average. It's just the average of all your phenotypes. And you can figure that out by environment and also averaged across environments. So this operational breeding value is much simpler than the theoretical breeding value. And part E basically gets down to what's your combined analysis of variance across everything. It's not the regressions or anything like that. It's the analysis of variance that you would do if you had a set of lines from several families, and they're evaluated in 2 different environments with a different replication in each environment. Does that make sense?
Yes.
How about the others?
I think so.
Okay. So for part E, you don't have to worry about these regressions. Okay, just have to go back to your basic analysis of variance for your full simulated data set. It occurs to me that let's clean this up. I'm might save this and fix it because I'm going to have to do some of this stuff myself. Make sure I can also do this. LA 16 and okay, so there's the ALA code for that. I can start getting rid of all this other stuff. So something that occurs to me that I think is still maybe not real clear with the simulations, and that has to do with, you know, what's the residual variability. Let's see if I can find that. So the residual variance, how do you figure that out? The total residual variance. Remember, it's a function of if you know the coefficient of variability and you know the mean, you can come up with what is the residual variance. So the CV is 8%. Okay, and so it's 8%, and I said it doesn't matter which environment you're in or which family you're dealing with, it's 8%. And so you just, you know, take 8%, and this is times G3, and you square it. And here it's 8% times 205, and you square it. So that's how I come up with the residual variance. And then that residual variance is used here, depending on if I'm in E1, then I have this, well, this here should be this would be E2, the way I've written the code here. So this is, I take essentially this value here, which is the residual variance, and I take the square root of that thing, and that's going to be my random or residual standard deviation for generating these random values. And I didn't do that, and that's why I was getting these funny plots where I only had 3 data points, or in some cases 6 or 8, data points. But it's because there was no associated phenotypic variance. One of the things that another thing that you may want to think about doing is you could talk about a genotypic value. Okay, so the genotypic value is just, the sum of these guys here. And that genotypic value, it's kind of instructive to say, well, if I plot out the genotypic value, and it's pretty obvious whether it'll be for the first family, it's going to be either 15 or negative 15. Which would tell you that you would have a very bimodal outcome. Even if you throw random variability on it, you'll still get a very bimodal outcome. And that's kind of what happens here. But on the other hand, if you have three loci that are segregating, as in family B, and you plot out just the genotypic values, they're going to look fairly close to normal. Even though you don't have any random variability associated with it. So very quickly, you can go from 1 to 2 to 3 loci, and very quickly basically end up with a histogram that looks like a normal distribution with only 3 loci. And in an F2, that happens really quickly. I don't know how quickly it happens in DHs. Haven't looked at it, but and you can sort of think about it as there's eight possible genotypic classes, and you'll have some sort of even distribution around those 8 genotypic classes. Are there any other questions about these, about ALA 16?
I don't have any.
Is it much clearer now about how to go, what the steps were, even if I made a bunch of mistakes along the way? Is it clear what you should be doing?
Yeah. We had, or everybody that was on the past night, and some of them the past 2 nights, I think are on track.
Okay.
So, yep.
John, did this help out? I know that today in class, I didn't see your note early until after class, so I probably should have gone over this in more detail in class. But I figured maybe this evening, if we went over it with a big enough group of people, it would spread to the rest of the class.
Can you hear me?
Yeah, sure.
Oh, good. Well, I've been having audio problems. I'm back down in the Twin Cities, so I'm on my iPhone.
Oh, okay.
But anyways, regardless, yeah, from what I was able to pick up, it does help to make more sense. And I'll grill my fellow students earlier too.
Okay. Well, I'll watch the discussion over the weekend because I won't be traveling or anything. So if I see anything that needs clarification, I'll suggest that we gather around the screen sometime and clean it up. Okay?
Okay. Yeah, sounds good.
All right, everyone. I'll see you on Monday or sooner if necessary.
All right, thanks.
Okay.
Thank you.
You bet.
So tell me you guys took lots and lots of good notes.
Yeah, and Lawrence is on here, so it should be recorded.
Crying out loud every time.
There we go. So what did you say, Michelle?
Yeah, and Lawrence is on here, so I'm guessing it's recorded too.
Okay, but you have a good understanding of it now?
Yeah, I mean, I think we're pretty much on track for the Excel file, how we did simulations. I think 2C, it seems like doing the graphs is what we need, right, Chelsea? So you guys were on track there. I hadn't actually run those yet.
So what Chelsea and Cassandra did last night was correct.
It seemed like he was doing the same thing that we were doing last night.
Yep.
Good. I know it's going to be more work, but I'm glad you guys did not waste your time.
Yeah.
Good. Okay. Well, as long as we're walking somewhat, was there anything that we screwed up on?
I don't think so. I came in a few minutes late, but
Yeah, I don't think there's anything we actually screwed up on. I think it was just a matter of getting the full way there.
yeah. So do you feel pretty good about 2D
That's
now?
kind of what I was worried about.
Chelsea, do you feel pretty good about 2D now?
I don't have anything.
Well, I had to look at what it is again. I haven't really gone too far past 2C, because I was just trying to figure that out last night.
Yeah.
That was the one involving Bernardo's book.
Yeah, the breeding
Oh, right.
values. Yeah, it didn't seem too bad.
Yeah. My big question is are any of you going to be on tomorrow night after 6?
It'll probably depend on how much I get done tonight. I'm hoping I can get most of the way through
Yeah,
it.
okay.
Have my Saturday.
Yes. So I'm hoping.
Yeah, well, I was just going to ask if somebody wanted to jump on tomorrow night about 6 when I get back, just to
Yeah, I could probably get on
cover
for
it
a little
really
while.
quick. I'll look for the videos. Okay, thank you.
Yep.
Oh. It's been a week.
Yeah.
I'm just glad that we were walking in the right direction and that it wasn't like we had completely screwed up. I sent him an email this morning hoping he would talk about it during class, so that's what he was referencing there at the end.
Good.
So,
All right. Well, good.
it went for about an hour, so he must have had a good discussion.
Yeah. I mean, he kind of just went over like the simulation and everything again. So I mean, it seems like everything we have is on track.
Yeah, that's an impression I got as well.
Just need to cut out a bunch
Okay.
of what we did
Yeah, and
already.
Yeah, that's what I'm like. This is gonna save me time now. It's gonna make me more time for me.
Yeah, I was almost thinking, do I really need to change my file, or do I only need to run data on the parts that are included now?
Yeah, I was kind of thinking the same thing.
Yeah, see, I haven't looked at the file, so what did he cut out or what did we change?
So in question 1, where before you were doing 6 loci, it's down to 4, I think.
Okay.
I don't actually have
we're
it
done with
downloaded.
one, aren't we?
Yeah, and then in question 2, where there were like 9 different total, now there's only 4.
Yeah, because there's only 2 families now, right?
Yeah. So just cut out a family and the rep and an environment or whatever.
Okay.
So,
Wow, he really did cut it back.
Yeah, is it just 2 families and 2 environments now?
I'm pulling it up right now. Yeah, 2 families, 2 environments.
Yeah.
Or I guess question 1 still has the 6 loci, but it's down to 2 lines, not 3.
I guess my only question is, was it yesterday that he was talking about those, like if you do the first 3 loci and then, but we're still supposed to like compare them to the 3 loci that we didn't simulate? Do you remember him saying something about that? Was it yesterday or the day before?
I don't
I wanna say it
know.
was in office hours.
Briefly, he said something last night about that, but I was not paying attention as much as I should have.
Yeah, I can't remember exactly what he had said. And even after what he went over today, I'm like, I still don't understand how we do anything with those other 3 loci that we didn't simulate, because you need the simulations to run the regression.
Yeah.
So I don't know.
I think he should just do it. It sounds like, from what he was saying, is that he there's a lot of stuff that he kind of stutter-stepped through tonight. Little mistakes he was making or something. I don't know. What was he referencing? With
Yeah, just because he didn't go through and do like the whole residual and get the different values, so then in R it wasn't really representative of what we would have. Because
Yeah,
it was
that's
just
what I
showing like
thought I heard.
6 data points instead of a ton of them.
Yep. Okay. Yeah, I kind of jumped in and finally got the audio to work so I could hear kind of about that point where he was showing the plots in R and trying to explain why he only had a few dots or 2 points. I can't see anything. I'm just listening, by the way.
Yeah, that's what I was guessing.
Good. Good guess.
Okay. Well, good. So, are you guys hanging around tonight, or just working on it? And
I think
Jacques,
for
I know
now-
you were off.
I think I'm gonna go grab some supper and stuff, and then maybe get settled in and work on it after that.
Okay, because I'm going to work on it tonight, but I was debating whether anybody was going to be on or if I'd just hop on a little bit tomorrow morning and review.
Yeah, I might work on it
will-
on my own tonight, and then maybe hop on tomorrow too.
Okay, sounds good. I'll plan to do that too. Sometimes it's just nice to get in a groove and get it done. And I feel like we're in a good place right now.
I'll be on after 6 o'clock tomorrow night, I think. That'll work.
Okay, I'll plan to get on for a little while.
I appreciate that. Anybody else that needs help or wants to help me, that'll be available. But I'd rather get it done tomorrow night than to wait till like Sunday or something like that.
Yeah.
Me too.
Yeah.
The sooner the better.
Yeah.
I don't have a computer until tomorrow night.
Gotcha.
Yep, that
All right,
works.
so I guess I'll jump off then. Thank you for sticking around, and thanks for whoever's going to show up tomorrow night ahead of time.
Sounds good. Have a good night.
Thanks. You too.
See you guys.
Bye.
you on, Tyler?